Everyone. These were a couple of the common homework questions. So I just wanted to talk through them and hopefully clear up any questions that you had. These are all from 4-7. Our first question here, number 7, was from the classroom exercises in 4-7. And it asked you to draw XY. I'm going to just do the best that I can to draw this with a midpoint. It's probably not going to be perfect, but we're going to pretend like my midpoint Q here is right in the middle, but I'll mark my diagram up so that it looks like it's in the middle. And now I want to draw a point P so that it's the same distance away from X and Y. So I could pick any point P that I wanted, but basically I'm kind of thinking about having like, I don't know, 2 rulers and they're stuck on X and Y, and then I want to have them meet up at whatever length I decide. When I do that, I think that you'll find that you have to be somewhere in the middle here. So here's point P, and my ruler connected to Y, says, I don't know, 10. And my ruler connected to X also says 10. So in our picture, what do we know? We know that those two are the same. That's PX and PY that they asked us to draw. And now we want to draw PQ. And so when I draw PQ in here, I'm going to end up with 2 triangles. And what do we know in this picture? Well, PQ is the same as itself. And so for question number 2, we now have side, side, side. Once we have side, 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 now I can use CP-CTC to show that PQX and PQY, or here angles 1 and 2, would be congruent. And then now that I have 1 and 2 congruent, how did I create 1 and 2? I created them with 2 lines, and I have congruent and adjacent angles that are created with 2 lines. And so that implies that we have perpendicular lines. What is the best name for PQ? Well, now I know 2 things. I know that it goes through the midpoint, and I know that it's perpendicular. So that is going to be the perpendicular bisector of segment XY. Number 10, again in the classroom exercises, is very similar. Number 10, though, we're drawing an angle. So this time, I'm going to draw my angle, and I know I'm going to bisect it. So I'm going to draw my angle N fairly large. Here's angle N. I want to draw NO so that it cuts this angle in half. So again, I'm going to have to kind of estimate, but I'm going to pretend like that cuts it in half. And I'm going to show it on my picture with my 2 congruent angles. Now let's see, if I have point P, and point P is somewhere on NO, what can I conclude? Well, this was one of the theorems that you wrote down in your notes. If you are on the angle bisector, you are equidistant from the sides of the angle. But what the heck does that mean? When we are talking about distance like this, I don't want to just draw any distance P over to my angle, because here, if I draw these couple, those are all different lengths. So when we're talking about the distance, we're talking about the closest distance, and that is always going to be dropping perpendicular down to your side. So when I drop perpendicular down here, those 2 distances are now the same if P lies on right and O. If I know that the distance from point P to each side of N is 13, well, I'm going to be really lazy here. What if I just say that that thing that I just measured is 13? Well, now, again, it's kind of like above where I have my ruler. My ruler is set at 13 long, but it is also set at being perpendicular here. When I have that, now point P just becomes point Q, and it lies on the angle bisector. Okay, so we'll see these in our notes that I will post as well. However, these were those two theorems that we talked about in section 4.7. For question 19, this was from the written exercises. And for this question, there's 3 separate questions that they're asking, so I copied my picture 3 times. A town wants to build a beach house on the lakefront, and it wants to be equidistant from the rec center and the school. If I want to be equidistant from these 2 points here, well, what do I want to be on? I want to be on the perpendicular bisector. And so here's my perpendicular bisector. I'm going to pretend like I drew that perfect and I measured, and it's right in the middle. And so where would the beach house be? The beach house would be right about there. For our next question, I want to build a boat launching site that is equidistant from the 2 roads. So here's one road, here's the other road. I want to be equidistant from these 2 roads, so I want to be on the angle bisector. So here's my angle bisector. We'll pretend like that's pretty close. And so here, I want my boat launching to be right there. Excuse me. Lastly, I want for my flagpole to be the same distance from these 3 points here. This one is a little bit harder, and I think will make more sense after the class notes. But for this one, if I want to be equidistant from all the vertices, I'm going to need to draw my perpendicular bisector of each side. And when I do that, I get this point right here, and that is going to be point F. Come back to C after you go through the class notes, and hopefully it makes more sense. All right, thanks everyone.